morning, guys. If you haven't done so, please put your homework 2 right there. What I will be doing now is to give you back your homework 1 and quiz 2 and quiz 3. Okay? Valerie, Raquel, Bossy, last name Bossy. Eric, Jensen Walter. For those who have missed it, you come to me after class. And yeah, I'll give you after class. Maybe I missed it. All right. So before the TA comes here, just want to quickly start our lecture today to work on a little bit of relational calculus. So as you can see, the slides today, we have some queries that we're going to work on. Some are new ones, so the number that are exceed 10 are the new ones. And we will work on both algebra and calculus for that. And for those that we have done before, which are the numbers less than 10, then we will only work on the calculus today. Okay? So let's start from query 12, where it says, find the names and ages of sellers with the rating above 7. So if we are only doing it in relational algebra, I guess this is already very easy for you guys, right? What would you do first if you want to solve this query in relational algebra? We want to first find the sailors who have ratings over 7. So we will use what? Selection. Select on what? Rating greater than 7. And then we apply this sellers, right? And what's the next step if we want names and ages? I project on the name and the age. So up until here, it's really simple. We're really familiar with relational algebra. Then I think the next page I asked you to write calculus, right? So for the first one, I'll work through it first. Then for the later one, you can think about it. So we want to sort of map that, map calculus from algebra, in a sense that, remember the format of calculus? What will be the most outer thing? Curly braces. Okay, so let's say we start from a curly braces. And on the left-hand side, we always give the tuples names. So let's say we just name it P for now. And we put the criteria on the right-hand side. And look at here, we only involve one relation this time. So let's say we say there exist S that are in sailor. Okay, so that's the first thing you want to write down. And we'll work on criteria. So the first criteria we want to think about is this one. Okay, we want only the sellers with rating above 7. So what do you think should be the first one we will write down? S dot rating greater than 7. And for now, we only have S happening here, so we want to somehow make sure that we then generate 2 fields right here, which are S name and age. So let's just assume we already have result, and the result have two fields. One is S name, one is age. Where will those field values come from? They come from S. So what we can do is we just simply by saying n, the PS name is from the S name. You by simply putting equal to and keep going. And PH will be equal to SH. And close the criteria with another parenthesis. Close the whole formula. You close the braces. So that's how you will work on relational calculus. Kind of confusing. So if you take a look at relational calculus and relational algebra, you can see the way we're thinking for different approaches are a little bit different. When we look at relational algebra, it's more like how we are going to retrieve the data, but relational calculus is more like presenting how the results should be. So here we say the result tuple should be this, and we describe what it is like. So that's for relational calculus. Any questions so far? Then let's try out query 13. I'm sure you can write down the algebra for that. So try to write down the algebra where we want to find the sailor's name, boat ID, and reservation day for each reservation. So who can tell me what are the relations that will be involved into this one? How many relations will we need? Two. Which two? Sailors and reserves. Yeah. Why do we need both? Because the BID is already in reserves. Okay. So what should we do for sailors and reserves? We join them. Right. So the query wants us to find sailor name, BID, and day. What do we want to do? Project on the field we want. So that will be S name, BID, and day. So the relational algebra for this one is really simple. That's it. So let's think about how the relational calculus will be then. We also start from a P, that would be the tuple variable, or we say the result relation. And if we want to follow the same way we did in the previous query, how will we start? Take a look at here, we have two relations involved. So what will be the first thing you want to write down? Yeah, there exists S that's in sailor, exists R that is in reserves. Okay. How should we work on the condition? Do we have any selection in the algebra? So, because there is no selection or whatsoever, we just have to make sure the SID here is equal to the SID here. Correct? Okay. So let's start from the first thing. I'll write from here. So you say the SID in S will be equal to the SID in R. That's the first thing. And this is sort of saying the same idea as a natural join, right? Or we can say equity join because we're just comparing for the field with the same name, whether they have the same values. What next? Take a look at the P. P has three fields, which is S name, BID, and day. So what would you do next in these conditions or criteria we said, so that you can make sure those fields have values?
S name come from key.
Key S name is from S name, and is from R. Okay. Finally, the last field, P day is from day. So that's it. So having worked on the first one, which is query 12, now query 13 seems to make more sense, right? So that's for query 13. And for this exercise, we actually have a query 14, but before we do that, I want to quickly go back to a couple of queries that we have worked on before, which would be 1, 2, 7, and 9. You guys all got here, this part? So let's go back to our very first one, which is to find the names of sellers who have reserved vote 103. Since we have already worked on this before, I'll just quickly write that down. And the version I'm writing down is sort of ignoring whether it's optimized. Okay, so here is for the relational algebra. If we want to find the sellers who have reserved vote 103. So we want to first associate sellers and reserves by using join. And we select those rows that the BID is equal to 103. We finally select the S name because that's what we want from the query. So how would you proceed from here to write down the relational calculus? Start from the curly braces. Say, same. Tuples P are in the result. So again, what are the relations involved? Sellers and reserves. So how should we start? There exists S, that belongs to sellers. Also, there exists R, that belongs to reserves. Okay, so that's how we want to start. And this time we have selection. So what should we do?
Join.
Yeah, we have. We can start from there as well. So let's say we want to say, because we join them, so the SSID will be the same as the one in R. Okay, so that's the first part where we take care of the join. What's the next thing you will want to do? RBID equal to 103. Correct? What's the final thing, since we want the S name? So P dot S name, where is it? Where does it come from? So, right here, the first term takes care of the join. Okay? How about the second term? Selection. And the final one? Projection. Awesome. So that's for query 1. If we go back to the query 1 we have worked on before, this is how we would write in terms of relational calculus instead of relational algebra. Any questions? Then we want to try query 2. So in query 2, we want to find the names of sellers who have reserved a red book. I'll quickly write down the algebra first. So we want to find the seller name. This is the first approach of writing it. Another one you can do, which is actually less optimized, but easier to think about. Take a look at these two relational algebra expressions. Do they generate the same result? Yeah, they do, right? But which one's intermediate table is smaller? The first one, because we do selection at the very beginning, so we avoid when we're joining them creating huge tables. Let's try out the calculus. So actually for those two approaches, we can write down different relational calculus based on that. I'll call that the first one, and this is the second one. Let's try from the first one. And let's try from the second one. How would you start? We always start curly braces, P, couple P, that satisfy. So what would you do first? S from sailor, S are in sailor, R in reserves, B in boats. There exists S, that's in sailors. There exists R, that's in reserves. There also exists B, that's in boats. Okay, so here, good, we take care of the join. Okay. What next? Take a look at here. BID? BID what? Okay, what do you guys want to do? If we are trying to write based on the second one. How about we start from the selection? Then what would you do? B color equals to red. Okay, so that part takes care of the selection. Okay. What next? Do you want to take care of projection or join? Either way. let's look at join then. So let's say we want to take care of the join, what should we do? R dot BID will be equal to B dot BID. Perfect. Yeah. Anything else we're missing? No, that's for join. What should we do if we want to then finally take care of the projection then? P dot as name comes from Sailor's as dot as name. Okay. All right. So that's for the first one. The second one. So you also can see here, this term we take care of the selection. This term we take care of the joint. Finally, we take care of projection. So if you take a look at this relational calculus, all of the terms that we have in the condition, does the order matter? I kind of just don't care. We just think about it and then we put it down, right? So the order doesn't matter. We just connect them with and. Okay, let's think about how we will interpret the first one. Also, we start from a P that's satisfied. What would you do? So this is a little bit trickier, so I'll work on it. So we want to first say there exists S that is in Sailor's. There also exists R that is in the reserves. And up until here, we just basically say, we take care of the things before here. Okay? We'll basically say, so in order to join them, the SID from S should be equal to the SID from R. Okay, let's ignore the both. And then we also take care of the projection where we say, okay, the S name from P will be coming from S. So far so good, but we haven't taken care of here. So what we can do is actually continue saying, and there actually exists B that is from both. Okay, it's kind of weird here, so we say, and so there exists B from both, where the BID from R will be coming from here, and also the color is red. This feels a bit weirder. Okay, so let's start from the very last one. So you're basically saying there exists B that are from both, where we can associate the BID in both to the BID in reserves. That's what the first one is saying. And then you're saying also, I only care about the both who has color red. Okay? So when we look at here, this is joining with reserves, but not thinking about Sailor's file. And when we look out back, we look back here, and then you're saying, okay, I'm joining Sailor's and reserve by comparing SID has to be the same, and then take care of projection, saying the result S name comes from S. So that's it. though this is more optimized when we write down in relational algebra, when you interpret it, it's a bit convoluted, a bit more complicated. So that part is a lot easier. Any question for that one? So if in the test I ask you, I don't really care about which one you write, okay? Let's take a look at query 7, where you want to find the names of sailors who have reserved at least 2 boats. And you want to tell me what we did in relational algebra when we are working on this? I think it was William?
Yeah.
It was you that you answered this one, right?
Yeah.
So what did you do?
The join,
Mm-hmm.
and then renamed them and compared the 2 BIDs to make sure they're
Yeah, you join which 2 relations?
it was reserves with reserves.
Mm-hmm. You join reserves with reserves, and then we rename the field to avoid the naming conflict. And we keep the rows where SIDs are the same, but BIDs are different. So that's what we did in relational algebra. Let's not write that down yet. But if you think of it, okay, I say the output is here. If the output in the end, because we are asking for S name, so we only have S name, right? And input will be, because we want S name, so it has to come from sailors, right? So we have SID, S name, rating, and age. These are from sailors. Then we finally have SID, BID, and day. That's from reserves. But instead of having just 1 copy of it, we have 2. Correct? Okay. So let me say it again. The input, we take it from sailors. Reason being, we want the S name. Another 2 inputs are both from reserves. Reason we need 2 is because we want to see which sailors have reserved at least 2 boats. And we want to make sure we can compare the BIDs are different.
Would it be easier now that we've covered the count aggregator, just use that?
So then, yeah. So if you do that, let's quickly work on the aggregation then. I'll do it there. So right now we weren't using aggregation because the calculus cannot be directly translated from that. But let's quickly try out aggregation since we mentioned it. So let's say if we are going to work on aggregation, what would you do? Aggregation always starts from alpha. Do we need grouping for this?
Yes.
Yeah. What do we group by? SID. What's the input? Yeah, we can just use reserve first. Then what's the aggregation function? Yeah. Count the ID. Right? So that's argument 1, the grouping criteria, argument 2, the aggregation function. So let's store it quickly somewhere. So what will temp looks like? How many columns will we have? 2, which are? would we do? Let's say we want to get the SID who have reserved more than 2 votes first.
We have to know the
Select where the count BID greater than or equal to 2. Okay? And we select 10. But for now, this will give us still 2 columns, right? And what's our final goal? We still want the name, right? So we can join with sailors. Either you want to do projection here or later, it doesn't matter. If we don't care about whether it's optimized. So let's say we join with sailors. And what do we finally do? If we want the name. Project. Okay. Finally we just project names. Yeah, that's a good one. We worked on that for relational algebra using aggregation. Any questions for that? Okay, let's go back here. Again, get back to our relational calculus. What would you do for this one? Let's switch our brain back here. So, tuple P satisfy what? A hint right here, since we have 2 reserves. Let's call one R1 and another one R2. So how will you start with the exist lines? Okay, we start from S, that is from sellers. Okay. Then we have R1, that is from reserves. Okay. Then we have what? R2, who's also from reserves. And then, so that part takes care of just saying how many relation we want to use. One next, which do you want to take care of? Let's say we want to use projection first. And here we only have the S name. So what will the projection be? The S name in T is from not yet. Let's say we want to take care of the projection. S name from P is from S. S name in P is from S. Okay, and then Kwok said the BID. What about it?
BID is not equal to
Okay, so R1 BID should be different from R2 BID. That's the part we can take care of. It has at least 2 votes reserved, right? What else should we do?
SID is equal to R1, but SID is equal to R2.
S dot SID equal to R1 dot SID
Is equal to R1, but
then we only keep one equal in a term. So then, what should we do for the next one?
And S R
Yeah. S, SAD, also, no, eh? Wait. Yeah, R2. Anything else? Close it. Yeah, the reason I paused it was because this is right, but then you want to be careful. Then we actually don't need to say, oh, then we join R1 and R2, so we should compare R1 SID equal to R2 SID, because this part already takes care of it. So that's for query 7. It's actually easier to think for this one in relational calculus than the one in relational algebra. Okay, we actually have 2 more. Okay, 2 more. But I think I'll leave 14 for you, and I'll work on 9, because I still want to spend a little bit of time talking about homework. In teams as well, in projects. Okay, let's take a look at query 9. We want to find names of sellers who have reserved all votes. What would you do for that one?
I have a clarification. Like in most of the cases that we were doing before, we were actually trying to match from the algebra and then convert it to calculus.
Yeah.
So in that we did it directly, right?
Mm-hmm.
So how, because I was trying to figure out from that. I was
Yeah. Actually, the reason I map it there, even though the end result is really different, just because we can think clearer what are the tables that would be involved and stuff. But when you really read this, it's just basically saying the result itself. Like the tuples. What are the criteria the tuples satisfy? But when we read the algebra, it's saying what are the process I'm taking to get the results. So it's still different. So yeah, like mapping it from relational algebra to relational calculus might be conflict with the core concept, because one is procedural, one is declarative. But for now, for the purpose of practicing here. Yeah, that's a good point. So they actually have really different purposes. One is for declaring what should the result be. One is for saying what should the steps be to get the data. But the reason I do that is because I want to kind of make sure you know what are the relations involved. Okay, query 9. We want to find the names of sellers who have reserved all votes. The keyword here is all. So what did we do for all when we were doing relational algebra? Division, right? So in relational algebra, we use division. Before we get in here, what do you think can be used for calculus if we're talking about all? For every, so that would be that thing, right? So we have, this is exist. And that's for every. Okay? So in calculus we use that. But when we are in algebra we use division. So how should we do? This is the one we want to use. Also, start from here. This is kind of tricky. I'll just work on that. So we say the tuples P. There exists S from sailors. Okay. And for, we start from here, for every boat. Okay, we keep reading like this. P satisfies satisfy the criteria where there exists S from sailors, and for every B from boats, there exists a reserves from, an R from reserves, which satisfy the condition that, let's do projection first. S name will be coming from sailors. And SID, this is for joining. And joining reserve. So if you read through that, we're just basically saying, for tuples P, it satisfies the criteria where S, there exists S from sailors, and for every B from both, there is reservation that satisfies these. Okay. Sort of tricky, but don't worry. I won't put too much emphasis on this. Okay. Yeah.
If we remove the bracket before the, like after the boats and before the reserves, like normal just
What are you saying? The bracket.
the outer one.
Uh-huh.
No, not the curly, obviously. Just the inside. Yeah, this one.
Huh.
This one and before the R for some R belonging to reserves. All of that.
Before where?
Like after boats.
Mm.
Yeah, the bracket just from
The opening parentheses.
the opening bracket for this. Yeah.
Yeah.
If we remove this.
I'll remove
it would be
it.
wrong.
Yeah, it's fine. So we are just adding it. But let's see. Oh, you're saying we would remove this, right?
Yeah.
Do you think it makes a difference? Same. I just put it because the interpretation feels more intuitive. Yeah, good one. Okay, we have a little bit of time. I want the TA to quickly tell you about the grading.
Did you all get the homework back?
Some are still here.
Okay. So I think you are doing a great job this time. And before you start to do some prep for the midterm, I want to focus on some points that you might get confused. For example, like for this time, I think the question 2 is to answer the data independence, right? And some of you might, I don't know where you get the idea, like the logical data independence is provided by the logical schema or something, or internal data schema. But I have to say, if you saw some similar answer from somewhere, just forgot it, because we need to focus on our slides, right? And Yisan and I both want you to focus on the slides since except for from the Wikipedia, right? And the third answer, the third question is, do you have the power for me? Yeah, the 3 is okay. And the 4, about the 4, I think the most problem is about the final, it's about the third question. It asks whether it's an attribute or something, what kind of attribute it is. And the correct answer will be composite. But some of you might answer the multi-value. I think that's okay, but if some kind of problem really shows in the midterm, I hope you guys will answer the composite. And if I give you like reduction of your points if you answer this multi-value attribute, just email me and I will give you the points back. And about the draw the diagram. Okay. I think the biggest problem is the question 5 about the final one. Yeah. If you read the problem very carefully, you will find there's one sentence that no one professor can, it is possible that no one professor can teach a class or a semester, right? But it also means that there is possibility that only one professor can teach that class. So you have to connect the professor and teach. You get it? Okay. So basically that's my point. Follow the slides and also don't forget or don't miss any entities or attributes. It might possibly to reduce some points. Okay?
Okay, so that will be it. If you have any grading issue, you can email Yanjing and to discuss with her. And if you are missing your homework,